Hello everybody, this is Mrs. Snook with section 4.6 day 2 notes. And today we are going to graph the cosecant and secant. So first off, let's get the cosecant. And I'm going to use a table where I'm going to fill in x's and y's. Across the top is the x, which is theta. And I'm going to put in for 0, pi over 4, pi over 2, and so forth. Then I'm going to find the sign at each place. And because cosecant is just 1 over the sign, I am then just going to take the reciprocal of each of my answers. All right, I filled in the chart, and I want you to notice that the cosecant is undefined at 0, pi, and 2 pi. So that means I'm going to have asymptotes at 0, pi, and 2 pi. So let's go ahead and sketch in those asymptotes. So here's the one at 0. Okay, so I sketched in the asymptotes in red. And I want you to notice that every pi, there's an asymptote. So 0, pi, 2 pi, also turn the negative side. Negative pi, negative 2 pi. And so what that means is our domain is going to be x cannot equal pi plus or minus n times pi. So in all multiples, all whole numbered multiples of pi, you can't have your x be there, and that's because there's asymptotes there. So I'm also going to say that my asymptotes are at x equals pi plus or minus n times pi. All right, the next thing I'm going to do is start plotting some points. And once we do that, we'll be able to see our range and our period better. Now, we have at 0, it's undefined. At pi over 4, it's square root of 2, and that's approximately 1.4. So when I plot that point, I'm going to put it in between 1 and 2. And then at pi over 2, it's at 1. And then 3 pi over 4, it's back at root 2. So what I'm going to get is this. It's going to go down and then through the point and then up. Now over here, when I get to 5 pi over 4, that's negative root 2. So that's going to be a negative 1.4. I have a negative 1 and then another negative 1.4. Go through these points and then head towards your asymptotes. And that's what it's going to look like. And because sine repeats, the cosecant also repeats, which means that what I see on the positive side of my x-axis is just going to repeat again on the negative side. So I'm going to pause the video and I'm going to sketch in the rest of the graph. Okay, so this is what our cosecant graph looks like. And then I want you to notice that the period, if I start here, this period is exactly 2 pi wide. And you'll notice you have 1 up and 1 down. And then if I look at the negative, I have 1 up and 1 down. So it has to do an up cycle and a down cycle to complete its whole pathway. So the period for this one is going to be 2 pi. Now look at the range. It only goes down to 1. And then on the negative side, it comes up to negative 1. So I have this area between negative 1 and positive 1 on my y's that's like a no man's land. It doesn't happen there. So then my range is going to be anything between like positive 1 up to infinity, as well as negative 1 down to negative infinity. And I'm going to write it like this. So I can start at negative infinity, and I can go as far as negative 1. I get to include the negative 1. And I'm going to start at positive 1, which I can include. I'm going to go all the way to positive infinity. That's one way to write this. Now the reciprocal of this function, just as a reminder, is the sine. So that's how I would do this graph. Now let's graph a different one. This time we're going to bring our friends A, B, C, and D to play. And just as a reminder, A is going to govern your vertical stretch or compress, and if it's negative, it'll flip. So vertical stretch or compress for A. B is going to govern the period. C, right here, that's going to cover your left-right shift. And then D is going to do up and down. So for this graph, I have A equals 2 right here. So that's going to cause a stretch times 2. And B equals 1/2. So what that's going to do is it's going to change the period. And our period is 2 pi over B. So I'm going to do 2 pi over 1/2. That gives me 4 pi. So my period is now 4 pi. So what that means is everything's going to stretch out from side to side. Now our asymptotes were at multiples of pi, but now because my period has doubled, the location of those asymptotes also doubles. So I'm going to have one at 0, another one at not pi this time, but 2 pi, and then 4 pi. And on the negative, it'll be negative 2 pi and negative 4 pi. So the first thing I'm going to do is sketch in these asymptotes. All right, so I've got the asymptotes sketched in. I'm ready to graph. Now I want you to notice that we have a stretch times 2. So instead of our graph turning around when it gets to y equals 1, it's going to turn around at 2. And on the negative side, it's going to turn around at negative 2. I'm going to show you what I mean by that. So right here is where it's going to go down and up, and it's going to come down as far as 2, not as far as 1. And then over here, instead of 1.4 for root 2, I'm going to double that. That's going to be a 2.8. So that's going to put it right about there and there. So now this part of the graph looks like this. And then when I go negative, it's going to turn at negative 2. We're going to have a point at negative 2.8 and another at negative 2.8. It's going to look like that. And remember, this repeats. So I'm going to have 1 in here, and I'm going to have 1 in here. And just a reminder that the reciprocal of your cosecant is going to be sine. And because this was a 2 and it's an x over 2, so this is sine x over 2. And because our a in front was 2, the reciprocal of that is 1/2. All right, next up, we're going to graph the secant. And recall, secant is 1 over cosine. So I'm going to take my cosine points, I'm going to flip them over and use those for the secant. All right, so I've filled in my chart with my cosine values at each of these locations. And I did the reciprocals. So now I am ready to go ahead and graph my secant. First thing I want to notice is that we have undefines at over here at 0. Anywhere I had a 1 over 0 is going to be undefined. So right here is undefined. Right there is undefined. So I'm going to have an axis at pi over 2, 3 pi over 2, Same thing on the negative side, negative pi over 2, negative 3 pi over 2. So each one of these asymptotes is going to be 1 pi wide. So let's go ahead and sketch in our asymptotes. All right, I've got my asymptotes sketched in place. I'm going to start filling in our table. I know my domain is x, and it's not going to equal any place I have an asymptote. And my asymptotes start at pi over 2, and then I'm going to add or subtract whole numbers of pi. So this is going to be a plus or minus n times pi. That's going to locate everywhere your asymptotes are, and thus places where your x is not allowed. And I can go ahead and fill in that my asymptotes are at plus or minus pi over 2 plus or minus a pi. Now, just like we did before, we're actually going to end up with one curve that opens up and another curve that opens down. And that together is going to make the period. So let's go ahead and graph this so you can see what I'm talking about. So we have at 0, we have a point at 1. And then at pi over 4, it goes up to root 2. So it's going to look something like this. And the same thing is going to repeat on the negative side, so I'm just going to sketch that in. Now I'm looking at 3 pi over 4. I have a negative root 2, so I'm going to put this right down there. Pi is negative 1, and then 5 pi over 4 is a negative root 2. So here's the curve that opens down. And that's where it's going to start repeating. One opening up, one opening down. So our period again is 2 pi. And just like before, it's going to repeat. So I'm going to have right here at 0. I had that. And this is where my graph cuts off, but it would actually keep going. And over here I have a repeat. So it's going to look like this. And then this parabola-like curve that's opening up, it's going to repeat over here. And I'm going to have a point there. And I'm going to have a point there. So it's going to look something like that. And what's happening is my graph is getting cut off at the end. So that's why we're only seeing partial curves there. So now look at the range. Well, the range can go down to -1. So like -1 to infinity. It can also go from -infinity to -1. So just like before I had this no man's land, I have the same no man's land between 1 and -1. So I'm going to say I'm allowed to be -infinity up to +1. So -infinity to, -1, including -1. And I'm also allowed to start again at 1, including that, and it goes up to +infinity. So that's my range. Reciprocal, so 1 over secant is the cosine. So this is what our secant graph looks like. Looks just like the cosecant graph, but it's been shifted a little bit. Let's go ahead and graph this one. We're going to grab A, B, C, and D. And just like before, A is going to govern your vertical stretch, compress, or flip. B is going to govern the period. C is going to be your left or right shift. And D is going to be up, down. So looking at this equation here, I have y equals -2 secant of 3x. So A is -2, and that's going to give me a stretch times 2 and a flip. And then B equals 3, so my period is going to be 2 pi over 3. So the first thing I want to do is put in my asymptotes. Now my asymptotes had been pi over 2, 3 pi over 2 on my original secant graph. But because my period has been divided by 3, then the location of each one of these asymptotes also gets divided by 3. So the one that was at pi over 2, multiply that by 1/3, and I get pi over 6. So I'm going to have an asymptote at pi over 6. And on this graph, that's right here. And I'm going to have one at negative pi over 6. So if you see, the space between my asymptotes ends up being 2 pi over 6 or pi over 3. And that works out to, on this graph, it's every 2 blocks you're going to put in an asymptote. So let's go ahead and sketch in our asymptotes. Okay, I've sketched in some asymptotes. Looks like some of them disappeared, so I can see if I can get them back. Okay, so here's our asymptotes, and I'm ready to start graphing. I have a stretch times 2 and a flip, so my no man's land, instead of being between -1 and +1, is going to be between -2 and +2. So what that means is when I go to graph, instead of starting at 1 and graphing up like this, okay, I'm going to start at 2. And because of the flip, I'm going to -2. So here's what this piece looks like. Now the next piece over is going to start here at 2. And then it's going to repeat. So here's 1. Here's 1. There's 1. So those are all the ones pointing up. Now the ones pointing down are going to be over here. Okay. And so that is how the secant graph is going to look. And I want you to notice how when we change the period to 3x, it squeezed everything in. So now we got way more cycles of this graph fitting on our grid. And the reciprocal is going to be, instead of secant, it's going to be cosine, and it's a negative. And this had been multiplied by 2, so it's going to be a divide by 2. So I'm going to get a -1/2 cosine of x is my reciprocal. That is it for today. Thanks for watching and have a great day.